Alright, so this chapter 3 is all about solving systems of equations, and there's a number of different ways to do that. We'll go through those during this practice test. Solving by graphing, substitution, elimination, and then towards the end, something called Cramer's rule, and then matrices. So part of this section is also on the different ways of operating on matrices. Okay, so let's get started with this. So solve by graphing. That just means you want to graph both of those equations and then see if they meet. If they meet, that will be the solution. If they don't meet, then there won't be any solution. So let's start by changing this to slope-intercept form. We'll subtract 2x. So we'll get y equals negative 2x plus 4. This has a y-intercept of 4. And then this slope means it's negative 2 over 1. So I'm going to go down 2 over 1. And I'll do that a couple more times. Down 2 over 1, down 2 over 1, down 2 over 1. That way I get the most accurate line possible so I can see exactly where these things meet. Okay, and then the second one, when we change this to slope-intercept form, we would subtract x from both sides. So we'll get 4y equals negative x. Sorry, that's supposed to be minus 12, so we'll make it plus negative 12. Divide by 4. So we're going to get y equals, this is the same as negative 1/4. And then negative 12 over 4 is minus 3. So that has a y-intercept of negative 3, and this slope means go down 1 over 4, and you can see they meet right at that point. What is that point right there? That looks like the point 4 comma negative 4. And you could easily test that by plugging that back into both of these equations, and they should both give you something true when you plug it in. Alright, same thing, number 2. Number 2, we will change these to slope-intercepts, so we'll subtract 2x right here. We'll get negative y equals negative 2x minus 1, and we need to divide by negative 1. So negative 2 over negative 1 becomes positive 2, and negative 1 over negative 1 becomes positive 1. So there's our first equation. It has a y-intercept of 1, and this slope is 2 over 1. So we're going to go up 2 over 1, up 2 over 1. And then I want to cover the left side of the graph too, so at this point, going up 2 over 1, that has the same effect as going down 2 and to the left 1. So I'll do that here. I'll go down 2 over 1 at that point. Down 2 over 1, down 2 over 1. Again, why are we doing that? So that we have the most accurate looking line possible, because you saw over here it ended up meeting at some precise point that we got by doing a couple of those up 2 over 1. So here this one is easy because the second equation, that is, we only have to subtract x, and it's automatically in slope-intercept form. That has a y-intercept of 4. And this negative, that's like negative 1 over 1. So go down 1 over 1. And there it is, they meet right there. That is the point 1 comma 3, which is the solution to that equation. Alright, second and third methods. That was solved by graphing. Second method is solved by substitution. And substitution means make your equation look like either x equals something or y equals something. If I look at the second equation, I have an x right there, so it would be easiest to solve for x equals. And I can get x by itself, because that's what I'm trying to do, by subtracting 2y. So x equals 2 minus 2y. Now if we look at this top equation right here, all I need to do is wherever I see an x, which I see one right here, okay, I meant to do that in a different color. Wherever I see an x, I'm going to substitute this thing right here, because we just saw x equals that thing. X equals 2 minus 2y. So let's do that. So negative x becomes negative this thing, negative 2 minus 2y. Then we still have the rest of that, minus 4y equals negative 4. Okay, so let's simplify that. So if we distribute the negative, do it above so we have more space. If we distribute this negative here, we'd have negative 2 minus negative 2y is plus 2y. And we still have the rest of this. We have minus 4y equals negative 4. 2y minus 4y is negative 2y. And we still have that minus 2. And then let's move the 2 over, because we're trying to solve for y. So we have negative 2y equals, what's negative 4 plus 2? That's negative 2. See what's being done to y and do the opposite. Y is being multiplied by negative 2, so I need to divide by negative 2. Sorry, it's getting a little bit messier than intended, and that means y is negative 2 over negative 2, y equals 1. Okay, the only extra thing we have to do is we now have to take that and plug it back into either of those equations. It doesn't matter which one. But remember that our final answer should have a solution for both x and y. So let's just plug it into x plus 2y equals 2. So x plus 2y becomes x plus 2 times, we just found that y equals 1. That was, just to recall, that was right here, y equals 1. So we're just plugging that in right here. Okay, so 2 times 1 is just 2, and then we'll subtract 2 from both sides. 2 minus 2 equals 0. So the point should be 0, comma 1, and it is. Okay, I don't know if you can see that amidst all the writing, but it's that one right there. That's written as a coordinate pair, so x equals 0 and y equals 1. Okay, number 4, we want to look and see what is easiest to solve for, and it's usually the ones that have a coefficient of 1 or close to 1. This one almost has a coefficient of 1. So let's subtract 2y from both sides, and we'll get negative x equals negative 6 minus 2y. I want that to be x equals, not negative x equals, so I'll divide everything by negative 1. Whatever I do to one side has to be done to the other. Okay, so negative 6 over negative 1, that's positive, x equals positive 6. Negative 2y over negative 1 is positive 2y. So here's our value that we can now take, and wherever I see an x, because I solve for x, wherever I see an x, I can substitute 6 plus 2y. Okay, so that is right over here. So I see an x right there, so negative 3 times, what is x equal? It equals this thing right here. Negative 3 times 6 plus 2y minus 2y, and then we solve by distributing this negative 3. So negative 3 times 6 is negative 18. Negative 3 times 2y is negative 6y. And then let's combine everything. So let's add the number to the other side. Okay, so oops, put a little, these problems tend to occupy a lot of space. And then the other side, negative 6y minus 2y is negative 8y. So negative 8y equals whatever that is, and negative 10 plus 18 turns out to equal 8. And we'll solve for y by dividing by negative 8, and y equals this number, 8 divided by negative 8, which is negative 1. So we need to take negative 1 and substitute it to either of these equations. I'll just choose this one. Okay, so over here, negative x plus 2 times negative 1, and that equals negative 6. Sorry, that's a negative 1 there. So negative x plus 2 times negative 1 is negative 2. So we will add 2 to both sides. And apologies again for the mess. Negative 6 plus 2 is equal to negative 4. So if negative x equals negative 4, then when you divide both sides by negative 1, you end up with x equaling 4. So our final solution should be x equals 4, y equals negative 1, and let me circle that a little bit clearer so you can see it. There's the answer right there. Usually x not usually, always x comes before y, just because that's what the convention has been for coordinates. Okay, how do you solve by elimination? You pick a variable to eliminate. It doesn't matter which one you pick, but in this case, the easier ones to eliminate would be the x's because they have the same coefficient. They both have a coefficient of 1. One of them is positive, one of them is negative. So if I want to eliminate, I can either add or subtract. And in this case, it would be better to add them, because if I add those two together, I'll eliminate the x's. So x plus negative x eliminates. That's just 0. Y plus 2y is 3y. And 3 plus 0 equals 3. So now we can solve for y by dividing by 3. You get y equals 1. Then let's solve for x by plugging in what we just found. So let's use this one, this top one. So x plus y equals 3. Well, we just found that y equals 1. So that's the same as x plus 1 equals 3. And you can solve for x by subtracting 1. You get x equals 2. So our final solution should be 2 comma 1, and it is. Okay, how do we eliminate over here? Well, in this case, neither of the coefficients have the same number, or neither coefficients are the same, so let's just pick one to eliminate. And it doesn't matter which one, let's just pick y. So notice this is 3y, that's 6y. I want them both to be 6, so that means I need to multiply the bottom one by 2. The top can stay the same. So the top one I'm just rewriting here. The bottom one, when I distribute the 2 to everything, I would get negative 4x plus 6y equals, and then 2 times negative 7 is negative 14. Okay, how do we eliminate this now? Well, negative 6 and positive 6, we can eliminate those by adding rather than subtracting. So those eliminate. 3x plus negative 4x is negative x, and 12 plus negative 14 is negative 2. X is being multiplied by negative 1, so I need to divide by it. And then x equals this number. X equals negative 2 over negative 1, which is positive 2. And now let's solve for y by plugging that back into either one, and I'll just pick the bottom one. It doesn't matter which one you pick. So negative 2x becomes negative 2 times 2, because that's what we just found x to be. and then negative 2 times 2 is negative 4, and then we will add 4 to both sides because it's negative 4 right now. So we get 3y equals negative 7 plus 4 is negative 3, and then we divide by 3, and negative 3 divided by 3 is negative 1. So our solution should be x equals 2, y equals negative 1, which it is. All right, a couple more elimination problems. Some of these, I mean, the method is always the same, but some of them tend to be a little bit more challenging. So here, we need to change either x or y to have the same coefficients, and it's a little bit easier to use x because these are smaller numbers. So another way of thinking about this is if you were adding fractions, suppose you're adding 1/3 plus 1/4, what would be the common denominator? And the answer is 3 times 4. The answer is 12. So I want to change the numbers in front of x to both be 12. I can change the top one into 12 by multiply by 4. So let me do that. So 4 times negative 3x is negative 12x. 4 times negative 9 is negative 36. And 4 times 6 is 24. I also want to change the bottom one into 12, and I can change negative 4x into 12, multiply by 3, distribute all that. So 3 times negative 4x, negative 12x. 3 times negative 12y is negative 36y, and 3 times 8 is 24. Okay, now how can we eliminate? Well, we don't want to add this time, because if I were to add negative 12x plus negative 12x, I would get negative 24x. So the way to eliminate them is by subtracting, because subtracting a negative is like adding. All right, you may notice something here. Negative 12x plus 12x, that eliminates, so that's 0. Negative 36 plus 36, that's also 0. And then 24 plus 24 is 48. So we get 0 equals 48. And the question is, when is that true? And the answer is, that's never true. It's never true that 0 equals 48. So how many solutions does this system have? It doesn't have any. Okay, nope, that's a mistake then. Something went wrong there. So let's see what happened here. 24, obviously. Oh, you know what? Here's the problem. I was supposed to have subtracted this right here, not added, because we were subtracting. So 24 minus 24, that actually equals 0. So now the question is, when does 0 equal 0? And the answer is always. 0 is always equal to 0 for every single x and y value, so that's how you get an infinite number of solutions. If you had done this, if I hadn't made a mistake, if it was 0 equals 48, that would be no solutions, because that's never true. But 0 equals 0 is always true, so you have infinite solutions. And if you were to graph those for infinite solutions, what that actually is 2 lines right on top of each other. Just to show you kind of a picture of that. If you were to graph this, here would be the first line, and then this other line is actually the exact same. If you graphed it, it would literally be right on top. It doesn't look the same, and that's because neither of them are in slope-intercept form. All right, let's do one more elimination, and then we'll start another video for the second one. So for this case, I want to make the same coefficients. Let's pick the y's this time, and the common denominator for 3 and for 2 would be 6. So I can change this top one into 6 if I multiply by 2 and distribute. So 2 times 4x is 8x, 2 times 3y is 6y, 2 times negative 9 is negative 18. And then what do I need to do with the bottom? I need this to be a 6 also, so I'm going to multiply by 3 this time, because that will make it 6. 3 times negative 3x is negative 9x, 3 times negative 2y is negative 6y, 3 times 7 is 21. How will we eliminate the y's? We can eliminate them this time by adding them. If we add these together, 8x minus 9x or plus negative 9x is negative x. Those are eliminated. And negative 18 plus 21 is positive 3. So we can solve by dividing by negative 1. X equals negative 3. And now let's solve for y by just picking one of those equations and plug in our x. So let's just take the top one, 4x plus 3y. That becomes 4x, which is, we just found it's negative 3. Plus 3y equals negative 9. 4 times negative 3 is negative 12. And then we can solve this by adding 12 to both sides. So that goes away, and negative 9 plus 12 is 3. 3y equals 3, so if we divide by 3, we're getting y equal to 1. So negative 3 comma 1 should be on that graph, and it is. Okay, in the next video we'll talk about how to graph systems of inequalities, which is section 3.2.